The sum of two numbers is 12. Their product is 32. Find the numbers. Find the numbers. Okay, so how many numbers are we going to find here? 1, 2, 3, 4. Says there 2, right? So we're looking for two numbers. The sum of two numbers is 12. Their product is 32. Find the numbers. So let's represent the two numbers. We represent first one of them. So let x be the first number. How about the other number? If their sum is 12, then what's the other number? If you know one of the number, if you have represented one of the number, then you can find the other number, right? So I have here, let's think of this. If the sum of two numbers is 6. Oh, let me just use 12 here. If the sum of two numbers is 12, one of the number is 5. How do you find the other number if their sum is 12? Anybody can tell me that? Their sum is 12. One of the numbers is 5. What's the other number? Can you tell me the other number? So that the sum of 5 and that number is 12. It's going to be 7, right? Because 5 plus 7 is 12. But this is not the case here. We do not know those numbers. Right, I repeat. So you can get the idea of how we represent the numbers. If the sum of two numbers is 12, one of the number is 5, what is that other number so that the sum is 12 when added to 5? It's 7, right? How did we do that? Just subtract the sum 12 by 5. 12 minus 5 equals 7. But the case here is both numbers are unknown. We do not know. So what we can do is we represent the first number as x. All right, so if the sum of the two numbers is 12, and the number we used to represent, the variable we used to represent that number is x. What is the other number? Do you get the idea a while ago how we got 7? We subtracted 12 by 5. But your x here is the number. So to find the other number, we do 12 minus not 5, but because we do not know that number, but we subtract 12 by x. Right? That'll be 12. That'll be 12 minus x. Let this be the other number or the second number. Whatever you want to call your numbers. You can say one number, other number. You can say first number, second number. It's up to how you describe it, because it's not described here like first number, second number, other number, one number. So you can use any description for those two numbers. So that's the reason why we can represent the other number as 12 minus x, coming from the idea that if you know one of the numbers, you can find the other number as long as you know the sum. Right? I repeat the example a while ago, right? If you have a sum of 12 and one of the number is 5, then you will get 7 if you subtract 12 by 5, right? But let's change the situation here. The sum of the two numbers is 12. One of the number is x. So how will you get the other number? It's the same concept. 12 minus x. A while ago, we did 12 minus 5 because we know that number. We do not know that number. We only know that to be x in this problem. So if your x is the first number, then we get the second number by subtracting, right? 12 minus x, just like 12 minus 5, which is 7. All right, but the case here is we do not know both numbers. So there's only one thing we can do. We represent the first number as your x. All right. Now, before we proceed to the equation, what if the sum is 20? The sum of the two numbers is 20. We do not know those two numbers. So how will you represent those two numbers? Your first number will be x, and the other number will be, well, you know the sum already, right? It's gonna be 20 minus x. You still don't get it? Why it's x and 12 minus x? So let me give you another example. All right. The sum of two numbers is 20. One of the number is 8. How will you get the other number? So your one number is 8. What number will be added to 8 to get 20? You subtract, right? 20 minus 8, 12. Okay, 20 minus 8 is 12. But what if the sum of the two numbers is 20? The first number is x. How will you get the other? It's the same concept, right? A while ago we did 20 minus 8. But now that your number is x, it will be 20 minus x to find the other number. That's the concept. Well, that's taking us too long for the first step, okay? But anyway, I just want to understand why we need to represent it like this. X and 12 minus x. So that next time you encounter this, you'll know how to represent those two numbers. Let's find the equation now. What's our equation? What's our equation? It says here their product, right? Their product is 32. So if their product is 32, then we can simply multiply x and 12 minus x. And that would be x times 12 minus x. And the product of these two numbers is 32. And we can solve for this. Okay, let us solve. By distributive property, multiply x times x, x squared, x times negative 12. Of course, that is negative 12. I mean, wait, mess up in here. I saw 12 to be x, but it's not. All right, let's repeat that. Goodness gracious. Well, let's multiply x times 12. That is, okay, I said x squared. Well, okay, it should be 12. It's gonna be 12x. And then x times negative x. And that's the one, the x squared, negative x squared equals 32. All right. And now we have here 12x minus x squared equals 32. Let's make sure we put all terms on one side, making one side 0. It could be the left side or right side. So now what we can do is we try to come up with an equation in standard form. Ax squared plus bx plus c equals 0. It's better if our a is positive. So where is ax squared? Ax squared is here, but it's negative. Let's make that positive. So we can make that positive by getting all these terms on the left side to the right side. And so let's do minus 12x to make that 0. So it's now the left side that we're making it, that we're trying to get rid of. So that side will be 0. Negative x squared, we add x squared. So we have negative 12x plus x squared. Now here, the result on the left side is 0. 12x minus 12x, 0. Negative x squared plus x squared, 0. But the right side is this one now, 332, negative 12x squared. These are unlike terms, so we cannot combine any of them. And so it would be as is, but we need to do reordering. We start writing x squared followed by negative 12x plus 32. So we have x squared minus 12x plus 32. Can we factor this one? All right, let's factor. We have 32, sum is negative 12. How will you get a positive number? It could be positive times positive, right? Your product is 32. So it can either be positive times positive or negative times negative. Which one must we use? It's the negative times negative because negative plus negative equals a negative sum. So it should be negative, negative. So remember your four cases. If you're factoring a positive number, but your sum must be negative, then both of them should be negative. Cannot be positive, positive, because positive plus positive equals positive. And what are these numbers? 32, whose sum is negative 12. What are these numbers whose product is 32? All right. No one's answering me. Only Gawache can answer. Jalawit can answer. 8, 4. Okay. Correct. That's correct. -8, -4. So let's write our vectors. We can write first -8, -4. Those are the factors of 32 sums -12. And the factors of x squared, xx, right? So we have x minus 8, x minus 4. Let's solve for this. Equation by setting its factor to 0. You have x minus 8 equals 0, or x minus 4 equals 0. Okay. You can listen to music later on. You can't do things two at a time. But if you are a multitasker, then you can, but not everyone is a multitasker. All right. So let's solve for x minus 8 plus 0. We add both sides by 8. What's your x now? X equal to 8. How about x minus 4? That's plus 4 plus 4. You have x equals 4. But these are only your x. Let's see if we have, okay, so if x is equal to 8, remember in your representation, your x is 8, the first number. We also need to find the second number. That's 12 minus x, right? What's 12 minus x? What's 12 minus 8? 4. That's 12 minus x. So these are the two numbers, 8 and 4. Their sum is 12. Their product is 32. How about here? You will get the same set of numbers. So if your first number here is x, then you have 12 minus x. Your x is 4. That's 12 minus 4. It's still the same set of numbers. 4, 8, 8, 4, same set of numbers. So no matter which x you use, you will get the same set of numbers. So what can we say about our answer now? Or can put your answer. The answers are, okay, or we say the numbers. The numbers are 4, and 8. We are done for example